So today our equation and slope is going to actually refer to special lines. So we're still writing the equations of lines, but now we're going to write the equations of special lines, given slopes and points as well. So, let's get to the second day. Our first two special lines are horizontal and vertical. A horizontal line is a line whose slope is 0. A horizontal line is a line whose slope is 0. The y value is a constant. So the equation of a horizontal line is y equals b. Where at any given point on your line, you have the point x, comma b. A vertical line is a line that goes straight up and down. A vertical line has a constant for x, and your slope of a vertical line is undefined. Slope of a vertical line is undefined. If you were trying to find slope using your equation, this is the case where you would get a number over 0. So a vertical line is the case where you get a number over 0. A horizontal line is the case where you get 0 over a number. We have parallel and perpendicular lines. Perpendicular lines, okay, are lines whose slopes are opposite reciprocals of each other. So when you multiply them together, they multiply to -1. Perpendicular lines are lines whose slopes are opposite reciprocals. So for example, if the slope of M1 was a half, then the slope of M2 would be -2. So opposite reciprocal. So when you multiply them, you get -1. Perpendicular lines will intersect at a 90-degree angle. Parallel lines have slopes that are the same. Parallel lines have slopes that are the same. Their b values must be different. The y-intercepts must be different. So parallel lines have slopes that are the same and y-intercepts that are different. We can write equations of lines that are parallel and perpendicular given a point. So we were given the equation y equals 4x plus 1. We'll treat that as our first equation. So it has a y-intercept of 1 and a slope of 4. That tells me it goes up 4 and over 1, or down 4 and left 1. So there's my original equation, y equals 4x plus 1. If it's going to be perpendicular, I'm expecting it to meet at a 90 degree. I'm given the point 5, negative 3. So that's going to like my x1, y1. The slope of the original line is 4. So the slope of the line perpendicular needs to be its opposite, so negative, and reciprocal, so 1/4. And then we plug in our x1, y1. So you get y minus y1 equals m x minus x1. Simplify. So 5/4 minus 3 is the same as 5/4 minus 12/4. So you get negative 7/4. And then we're going to graph our point. So your y-intercept is negative 7/4. That's kind of close to negative 2. If you plugged in the number 1, so when x equals 1, you have negative 1/4 minus 7/4, which would give you negative 8/4, which gives you negative 2. So that means when x is 1, y is negative 2. Now I would use that point to do my slope. So it goes down 1 and right 4, or up 1 and left 4. And we can see our perpendicular line. So again, your slope doesn't always have to start with your y-intercept. If you can find a point near the y-intercept and get it to be a nice whole number intersection point, then we can use that instead of the y-intercept. Sometimes the x-intercepts are nice to find because they are whole numbers as well. Okay, same idea, perpendicular to the given line. So our given line has a slope of 5 and a y-intercept of negative 3. So a slope of 5 tells me that the opposite reciprocal slope will be negative 1/5 through the point negative 1/3. So that's y minus 3 equals negative 1/5 x plus 1, because minus a minus. And then you get y minus 3 equals negative 1/5 x minus 1/5. Add 3 to both sides. So that's the same as 2 4/5, or 2.8. You could also have written it as 14/5. So again, there's a lot of ways to write the same thing. So your y-intercept is at 2.8, kind of really close to 3. If you plug in the number 1, that gives you 13/5. That doesn't really help. If you plug in the number 2, that would give you -2/5, and then 14/5 gives you 12. So that's not helpful. But if I plug in the number 4, then I get x equals 4. So you have -4/5 x, or 4/5 plus 14/5. So now you get that that's equal to 10/5. Well, 10 divided by 5 is 2. So what that means is that when x is 4, y is 2. And then you could apply your slope to that. So down 1 and right 5, or up 1 and left 5. Okay, same idea, different equation finding now. So now we have lines that are parallel. So now we're looking for a line that is parallel. So my original slope is 2/3, which means my new slope is also 2/3. So parallel lines will not intersect. They are the same direction. So both slopes are 2/3. So I'd have y minus 1 equals 2/3, x minus 2. So -4/3 plus 1 would give you -1/3. And again, if you're going to graph these, you're going to want to try to find an intercept that is nice and not a third. So again, if I plug in the number 1, 2/3 minus 1/3 is 1/3. Doesn't help a whole lot if you plug in 2. However, when x is 2, you get that y is 4/3 minus 1/3, which is 3/3, which is 1. So you have the point 2, 1. Which again, you could see was also our given point. Remember that once you know your given point, you can always start with that and use the slope. So we have 2/3 as our slope. So it's going to go up 2 and right 3. Or down 2 and left 3. Make sure when graphing a line, you always put arrows in opposite directions. A line has an infinite domain and range. In order to show or express that, you must have arrows on your graphs. So a line has an infinite domain and range, and in order to express that, you must put arrows on your graph. Now we could graph our original equation over here. So the problem with this one, though, is you have 3 2/3 and 5/8. So you don't have a like denominator. You could get rid of your denominator by multiplying kind of everything by 24. And helping to clear out your graphs. So you get 24y equals 16x plus 15. So at least now when you're plugging in, you can kind of try to find points that are similar. You could also keep it in slope-intercept form. You could have divided everything by 24, which would give you your equations that are nice and neat. In this case, there are really not very many numbers that are going to give you nice points. If you tried to find your y-intercept, you'd get 15/6, and your x-intercept would be 15/6, and your y-intercept would be 5/8. So you'll see that the two graphs are pretty close together, never intersecting because they are parallel. Parallel lines do not intersect. Okay, vertical lines. A vertical line is a line that goes straight up and down. Its slope is undefined. So if it goes through the point 5, -3, once you know your point, then you know if it's vertical, it goes straight up and down. So you just draw a line straight up and down through that point. The line is always going to be an x equals equation. And it'll always be the x value of the point it goes through. So in this case, x equals 5. If you picked any point on the graph you drew in, all of your x values will be 5. Okay, horizontal and through -2, 2. So you have the point -2, +2. If it's horizontal, then your slope is 0, because any other point you pick on that graph will make the numerator 0, because all of the y values are 2. So you're going to draw a line where all of the y values are 2, which means the equation of your line is y equals 2. I know this seems easy, but every time I give a test, we usually miss one of these. Okay, so that summarizes chapter 2 for the mid-chapter. So we've done lessons 2.1 through 2.4. We will be reviewing the mid-chapter over the next few days, and then your quiz on it will be next Monday. So for tomorrow, you're going to finish the 2-4 sets of homeworks. Make sure you upload those for tomorrow. And then you also have a Delta Math tomorrow. Answer keys will get posted to homework assignments 2.1 to 2.3 today or tomorrow, so you can use them to check.